G'day. I was asked to do a bit of repetitive machining work for someone the other day. Now normally in this workshop I do, well, you know, 1 and 2 off, maybe on a very rare occasion, you know, 4 or 5. But this was actually, well, 8 of one part and 4 of another and 4 of another. And so I started looking at stops and things to try and make that a bit easier. So this is just a bit of a collection of the way I set up stops on machines to, you know, be able to reproduce parts with a minimum of effort. The idea being you put a stop on and then you're only feeding an axis in one direction to achieve the desired goal. Sometimes you will set parts up, do a particular operation, take that part out, put the next part in, do that particular operation. There will be other times when, just because the way the parts are, because of the relationship between the parts, the features on the parts and the way they have to go together, sometimes you'll do several features and then change the part, or even complete the part and then do another one. But that depends on the part a lot. So this is just a collection of odds and sods. I hope it's of use to people.
Repetitive machining starts with your blank preparation. Here I have to cut 8 pieces at 250, so I've got a stop here set at a little bit over 250. I'm going to mill the ends just to clean them up, but it's only about 3 millimeters over length because I don't particularly want to have to spend lots of time milling when I could be cutting. Cutting's a lot faster. I can let this go and do other things while it's cutting. The other thing I've got here is I've got 2 pieces of material in, and I could have 3 or 4 or 5 or whatever. It's not necessarily going to cut much faster because, you know, you still got a volume of metal to remove with the saw teeth, but it means that I spend less time setting up. So instead of having to come over here 8 times to do this, I only come over here 4 times. I have done it before where I've cut things in half and doubled up again, so I only come over 2 times. But, you know, you're on a law of diminishing returns there. I've got a clamp here to keep things together because my stop only bears on one part there. Once that's cut through, I'll move that clamp up a bit to keep these in the same you know, relative position to each other. So that way I can just slide up to the stop and you know, go again. One final thing when cutting multiple pieces of stock like this in a saw, or for that matter doing things in a milling machine, is that you need to have everything lined up this way so the clamping forces are holding it together. If you do this like that, you might get away with it, but because of minor variations in the width of the material, imperfections in the jaws if you saw, all that sort of stuff, you might find that some of these can move relative to the others, and that's a recipe for broken blade at the very least. I have occasionally gotten around that with putting a business card, and a nice thick bit of card in there. Some people can use bits of copper wire and allow on that squashing, but as a general rule, cutting like that, unless you've got this, you know, firmly clamped, bolted together, whatever, is not a good idea, and the better way of doing it is like that. This is an interesting little locking plier, I guess, from Stronghand. Now, Stronghand makes some excellent welding gear. They're not sponsored, but they still make excellent welding gear. And this is a PE 6M. Now, the interesting thing about this is that it works in reverse, in that when you close it, it pushes out like that. And I guess the idea behind this was to, if you had 2, say, bits of tube or something, and one wasn't quite in the line, you could put that between and just, you know, push one out, and off you go. So it's an interesting little thing from that point of view. But I've actually discovered another use for this when I'm cutting off stock in the bandsaw, and I'll show you. And this is the use here. The vices on these bandsaws are notoriously sloppy, and to hold the material properly you really need to have enough there that you can grip it all over. In this case I've got a short piece here which I'm trying to cut off, and so I've got a bit of RHS in there, and then I'm using the locking ply here to give me a precise spacing. That's the same size as the width of the material I'm cutting off, and so that keeps my vise nice and square. So that's another use for this sort of plier. You can extend it any length you like, just with an M8 bolt here. So if you're in a welding shop and you see one, think about it. It's a handy thing to have. I'm up to the stage now where I want to trim these to length. And so what I've got here is the most basic of stops. I've just used a couple of bits of the clamp set to set up a stop here, and then when I position my blanks, I push them in against that stop, lightly tap them down in the vise, clamp it up, and off I go. Once I've done the first set, the position of my cutter is pretty much set, and because these things are reasonably close to length, it means I don't have to take two cuts, which is another good reason to cut things close to length. Some of you may have already worked out that I've just done something here which I said not to do, which was clamp your pieces of work in the vise like this. And the reason for that was that if one of these is oversized, the rest of them are loose. Now, these are an extrusion, and so they're going to be pretty darn close to size. I've also got a piece of business card here to act as a bit of a, what would you call it, to take up any slack. So in this particular case, I'm pretty safe. But it's not something I would recommend doing with, say, black bar stock or anything like that, where you're going to get some variation and unevenness in surface. These blocks require a slight angle on them. In fact, I've got a 3D printed version here. And it's around about 2 degrees. Now, this is one of those occasions where it's better to use a dial indicator than it is to try and work out, get a protractor set on 2 degrees and so on, because the total difference in height here is about 9 millimeters. So I've set it up for that. Now, part of the secret to being able to reproduce parts repeatably is having your stop set up. So here I've got a clamp style stop for a vise. They're not terribly complicated. They're just a couple of jaws that clamp either side of the vise with a screw to do them up. So that's one sort of stop I'm using. I've got some parallels in the vise to give me a depth stop there. Now, because I'm doing an angle, normally I'd have parallels in both of these vices, but instead what I've got here is I guess as you call it, a modified jack stand that I made up the other day. It's basically a jack stand, but it clamps to the table, and I've got a cutout there so it clears the bottom of the vise. And that gives me a height here. The top of it is rounded. It's similar to this one in that respect, and so I can set that and give myself basically 2 stops there and a stop there, and that defines the plane that sits on. What I'm doing is I'm putting an 8-degree angle on the end of these bars, and I've got 8 of them. So what I'm doing is I've got an angle plate set up for the 8 degrees. I've got a couple of stops, and they're doubly bolted down here to make sure that they don't move. This is actually square to the column, so as that moves, that comes back. I've also got a blue line or a bit of blue texture down the bottom there, and that way I can judge when my cutter is actually clean out the whole face versus stopping short. The alternative to that is some form of stop, but this is hanging out the back and this is hanging out the front, and I haven't really got the room for that. So basically I'm putting that up, zeroing it off on the blue, so when the blue just starts disappearing on that bottom edge, I know I've got the full cleanup. Setting that going. While that's going, I've got another part like this one which has just been done. And while this is machining, I'll deburr that and polish that up and all that sort of thing, so that it turns into that. I've got to do both ends of these, so there's actually 16 cuts to do. And that way I'm not just sort of sitting here waiting for the machine. I'm making good use of the time between the cuts. I have two sorts of vice stops available to me to use. There's this one here, which is a clamp-on one. The other one I've got is this one, and it's just a flip-up tab like that with a screw. Now this was case hardened, so I used a carbide end mill to get through the case hardening, and then I was able to tap that to put that in there. So it's an easy mod to make, but that does come in handy, and I could have used that for doing this part, except that it would have stuck out here where my cutter was going to go. So, you know, I've used this one, which is lower profile, but nothing to say you couldn't make up a whole range of stops, or even, you know, washer looking things to take care of that. These are similar to the previous aluminium blocks I was doing with the horizontal cutter to trench that out. Here I used a vertical cutter, used the same method, jacked this end up a little bit, clamped it, and off I went. This block has got to have steps put in it though. So usually when I'm working off this, I take I work out where the centre line is and I work off the centre line, and that means that on my DRO I can dial up you know, plus or minus whatever the distance is. It makes it nice and simple. This way, each one of these steps is going to be 50 millimeters long. So what I'm going to do is I'm actually going to locate the cutter off the edge of the part here, and that way when I'm in 50 millimeters, it's going to be the edge of the cutter, and that'll make it a bit simpler for me to keep track of what's happening. Lately, to keep track of dimensions, particularly when doing repetitive stuff, I've taken to get a bit of masking tape and writing the dimension that I need to aim for, and then sticking that up on the DRO, so I can dial this up to plus 12.06 or minus 12.06. By this stage, some of you might be asking, well, that's nice, but what about a lathe? How do I do repetitive stuff on a lathe? Well, a lathe isn't actually as well set up as a mill for repetitive stuff, because on a mill you've got lots of T-slots and things you can bolt on fixtures, that sort of stuff. On a lathe you haven't, you're basically limited. But if you've got an Allurus tool post or an import copy, you might notice this hole on here. Now this is actually designed for a stop. I don't think Allurus have made the stop for quite some time, but certainly when it was copied by other countries, they put that hole on. I'll flash up a still in a moment of what that stop looked like, but the idea is that if you put that stop on, you could bring out a bit of bar stock, wind your carriage up to where the stop is, and then part that off, or put a groove in, or whatever you want to do. So there are possibilities like that. Are things like this. This is a little stop I made up for the lathe chuck, and it goes in like so. It's just 3 bits of 5mm bar, but the idea behind it is that you can put that in the back of the chuck and push something up against that. So if you wanted to have, say, half a dozen pieces with a radius on the front, you could put that in the chuck, put them in there, and then you wouldn't have to move your cross slide back and forth that way. All you have to do is wind in, and it should put it in the same spot. I mean, the idea behind a lot of this repetitive stuff is basically the minimum number of moves on the machine itself. Other possibilities are you can put dial gauges on there so that you wind up to a particular spot, and I use a dial gauge quite often for the longitudinal travel to get that out. But that's, you know, probably, apart from having a DRO and so being able to turn to a particular diameter, that's probably about all you're going to do with a lathe. So there you have it. That's a few of the ways I set up parts for repetitive manufacture to, you know, get results like that. There are other ways to do it. If you've got CNC equipment, well, it all becomes very easy. If you've got a capstan lathe, it becomes easy, or easier, and all that sort of thing. So just this is how I do it with my manual machines. So thanks for watching, and we'll see you for the next one. And also thanks to David for throwing these parts my way.